It's actually a live coding session. As Kfir said, this is his first live coding session. So he will talk. He will show you the workflow of using Scala with TDD and to implement some interesting, I hope, features. So please welcome Kfir.
Thank you. Thank you. Good evening. It's my second time in Nipro, and thank you for coming. We made this talk exclusively for you. Me and Tomer make two talks, and I'm going to show you how we in weeks treat code, how important for us is TDD and Clean Code. The idea is not to show you how to do code in Scala, but to show you how to do Clean Code and TDD, and what with Scala tools. Any one of you is doing Scala? Good. Some of you do TDD? Good. And some of you do TDD which not in Scala? Okay, so I think we're okay. So let's start. Okay, so I'm Kfir. You know me from the I'm speaker in November, and I'm 17 years in the industry in many positions as developer. In the past 5-6 years, I joined Wix, and we moved Wix toward microservices and Scala. And in the past few years, we become fully TDD shop, so we do everything TDD, and we like clean code. A few more slides, I go over some definitions, then I will take a use case. Some people show TDD in some academic way. I'm going to show you a real production feature for microservices world, and we code it together and see how it goes and do some refactoring and so on. It's going to be fun. So definition. You can't talk about TDD without showing this circle. So the essence is, you write a failing test. After you have a red bar, you can only do the minimum piece of code to make this test pass. After the test is passed, you can do refactor for the code, you can do refactor for the test, but I specifically choose this diagram because I think this process is repeating endlessly. You always and always doing a refactoring, and this is the essence. And another thing most important is the Clean Code by Uncle Bob. You know Uncle Bob? So I think it's the difference between engineer and developer. And code is something you like, you're proud of, you want to come back and do. So I think it also go together with TDD. So there are many buzzwords around TDD and Clean Code. We touch some of them. And now let's go for the use case. So use case is, I have a server. It's a quiz prize server. This server, I did someone for Wix 2 years ago for Super Bowl campaign. The server gives you a prize. You need to click a button and give you a prize. So the user asks for getting a prize. The server goes to the database, return a price, return OK, and then you get money or whatever. And then if this user is doing it again, it goes to the server, and the server returns already played because we did a primary key, so it sends OK. And then we have a user which tries to get many prizes and so on, so it tries to bomb us. It goes to the server responds, already played, and eventually database is working hard for nothing. So what we're going to do today is a throttler. We call it a fail fast pattern. So if you go to get a prize, you go to the get prize, you get the prize, you get OK, and the next time this first line of defense returns you already played, and database is not have heavy load, and I call it a rolling window IP throttler. So yes, we may have n+1 servers, so it's not like exactly the amount of requests I want to. It's not like the authoritative transactional, but I want to reduce the load of my server. This one case, we can have more cases, like for example, you do a login, and there is a user that try to bomb you with login attempts. So you can be throttler by key. Key can be IP, or by email, or by the username, or whatever. And this is common practice we do in our microservices environment. It's like first line of defense when our developers need to know that when you put something on the internet, and if it's open, people will try to abuse it. Of course, database in this case will prevent us, but you don't want to load database. So we do whatever we need to do a fail fast pattern. So, any questions so far? Make sense? Yeah? Okay, so let's do live coding. I already created a project, an open one. And let's do it like this. Okay. You see it? We can increase this, maybe this. No. Okay. So, as I said before, we start from the test. So I'm going to create a new test. Rolling. Window. Throttler. Test. Okay. So, we're going to use specs. Specs2, you know specs2? Okay, so there is two main framework for doing tests in Scala. One is specs2, one is Scala test. We choose specs2, but they're more or less the same. So let's do extend specs with JUnit, mutable. And we're going to write our test in a specification way. Some people call it BDD, behavior driven design. Sorry about this. I just call it TDD, and the idea is to tell your test like a story, like a fairy tale in English. So let's start doing the test. So I do rolling. Wait a second. Something stuck. Window. Throttler. Should. And my first test will be, I want to allow the first request. So allow single request in. Now I want to create my throttler object. So I do val throttler equal new rolling window throttler. Okay, so I'm going to do create class. I like to start doing the class in the same file, so it will be easy for me to refactor, and then we extract it outside. So every time I do TDD, I write my production code and my test code on the same file. In Scala it's possible, in Java not, so it's easy for me. So I have my object. Now I'm going to do I call the request. We're starting from the user. I want to use something, so I'm write like I have it. So throttler dot try acquire. And my key is an IP, so I put like random IP. And then I want to do a matcher assertion, so I do must be successful try. And I'll get into it. So you see this red, I want to now create this function. So the function is, sorry about this, it's a key. It's return a try of a unit. You know what is a try? Okay. Try, you know what is try? Okay, try in Scala, wait a second, is an object, it's an abstract class which can have two types, a tryable exception or an object. So when you create a try, you can, it's like either monad, and you can transform it and so on. So I like my throttler to give me a try. In my try I can have exception, like throttler exception, or it's a true, so I can continue doing my code. And this is a matcher on a try. If you look at this matcher, it's try success matcher. So it's matcher on a try. Okay, so I have my code running, And let's now run my test. My first test, I'm going to run it. Okay, if it's missing, it's so let's now we have in a red bar. I want to write the minimum piece of code to make this test pass. So I'm going to just put a try, and let's run the test again. And it's green. Okay, so constructing a try can be either do try or try with a closure. So I can put a code inside it. Let's run it again. But if I throw exception inside the closure, throw new exception. Oh, sorry. Exception. Wait a second. So exception, it will be a failed try, and it will be failing. It's not a, and I can also do, instead of doing try, I can do something like this. I can do success of Scala util, which in a unit or whatever. Success. Let's run this. So I constructed the subclass of success. If I do a failure, unit is mean void. New exception, and it will be fail. So my first test will be success, and let's continue. I can do like this. It will be enough. Okay. Now I want to write my second test. My second test will be I want to allow a max amount of requests. So I do total second request which exceeded the max in. Okay. So my second request be failed try. Okay. I already have code duplication, but I have red bar. Let me show you. I have red bar, I have code duplication. I don't going to fix this code duplication. First I'm going to make the test pass. Then I will go to fix the red bar. So obviously we need a counter. So let's create a counter. I can do case class counter, which is I need mutation, so it's var count int equals 0 default. And then I add a function, so I add def increment and get equal, it's int. I do count plus equal 1, and I return the count. So let's save my counter here. Val counter. If you have question, please ask me. Case class is like, okay, case class is like a class, but it has its own name parameters, and it's like it's more of a object holder, more of the, let's say logic, but like a domain object. So I can do new counter. Yes, please. I agree with you. I agree with you, but I decided in this case to do a try. But yes, I agree with you. The real scenario I wanted to do is to have a closure, so I can have try on a closure. Then you write your code, and you can try a closure. But for simplicity of this talk, I choose a try, only for simplicity. Okay. So let's construct a counter. And I have counter, and then I have now counter dot increment and get equal no, okay, now I need to have max. Okay, so I'm going to have max equal 1. So I'm allow only max of one request. So max dot int equal 1 equals 0 1, which is the default. And now I'm going to do counter dot increment and get max and then if count success, else failure, new exception. Let's run the test. Okay, now test is running. Now I want to take care of my duplication of my test, so I'm going to now refactor my tests. So now I'm going to introduce you a scope. A scope is helping you to run tests in parallel. In this case, you don't have it, but for example, you have database, for example. So you can create a scope for each test, and you can generate random IDs, and you can parallelize your test. So let's do a scope. I'm going to do a class here, class, throttler, scope, extend scope of specification, and I do val a throttler equal new rolling window throttler max equal 1. Okay, and let's replace our throttler. Now I do in new throttler scope. I'm going to remove this and I'm going to remove this one. New throttler scope. Let's run this test again and see if it works. I also have got duplication in my IP, so I'm going to construct it once. So let's do val and IP equal 192.168.1. Let's do an IP an IP. Okay, so you see it's more concise. Now I have a green bar and the two tests are running. So now I want to check different keys. So let's do another test. Allow second request, but with different key in new throttler scope. And let's do like this, and so I'm going to have now val another IP equal 200, 200, 200, 2, 1. Another IP. So I have the third test, and let's run the tests, and I have now a red bar because my counter doesn't have the. So now I need to have like a map from a key to a counter. So let's create, we need a mutable map. So I do like val invocations equal Scala collection mutable. By default, Scala collection are immutable, but in this case, immutable. Hash map dot empty of string and counter. And instead of doing this, I'm going to do like invocation dot get or else update, sorry, of a key. And on the update, I'm going to create new counter. The second parameter get a function which grant you whatever new you want to do. So val counter equal this. And I'm going to remove this one. So So now my counter is taken from the map, and let's see if it's running. So everything is running. So what we did, instead of having one single counter, now I have per key. Now we start the fun part. Now I want to do the real rolling window. So let's make for fun, okay? So now, re-allow request after the rolling window in new throttling scope. And I want to do like this. Now I want to do some wait. And then I want to do another success. So, how can I do it? So, I'm going to refactor some of my throttler. I'm going to do some like, I want duration window. Let's say I want to allow every minute one request. So I do 1.minute. Okay, I personally like Scala finite duration. It gives you more descriptive way to define time. So I do 1 minute. You see it's red, so let's now do the relevant import. So import, sorry, Scala concurrent duration underscore. And I want to have the duration window, so let's have it now also here. Duration window equal finite duration. Okay. So now I need to do some wait. Okay. So how can I do it? I could have do sleep or something, but I want to do it. Yeah. So there is pattern called virtual clock pattern. You heard of it? Yeah. So I can give something called collaborator to my class, collaborator, which the clock, virtual clock, and I can programmatically run the time, like Back to the Future. I have a future machine. So let's create my clock. I have a val clock. So in Java 8 we introduce a clock. You know clock in Java 8? You saw the Java? So I have my fake clock. My fake clock is nice. So I have a mutation of my fixed clock. I can run by edge. So I can do new fake clock. And I'm going to pass my clock to the toddler clock equal clock. And let's have this clock here in my production code. Clock equal clock. I'm going to use Java time. Wait a second. Java time clock. Okay. So I have my clock, so I can do clock.age, which you get also for duration. I'm going to do 1 minute. Okay. So now I have a test is set up. I got one request. The second one is failed on the same key. I wait 1 minute. The rolling window is ended. I can allow another request, and then I run, and I should be successful. Let's run the test. Sorry about this. Okay, so it's failure, and I can see that it's not really allow. So now, instead of having a counter here, I want to save the timestamp when the user is do the acquire. So let's create another case class. We call it invocation. Case class invocation, which has timestamp. Instant is like the object represent the timestamp from the clock, and I have a counter equal counter. Okay, so instead of having a counter here, I'm going to have invocation. Now I have failing because I need to create new invocation. So I can, instead of this, I can do invocation, which gets instant and a counter. So instant I get from the clock. clock.instant and a counter. Okay, so instead of count like this, instead of counter, I can add it is invocation and counter invocation dot counter. I think I'm that. Okay, now I'll do some refactor. I didn't yet code the did the code that changed the time is passed, but I want to rerun the test that I'm green from what it did before. For my refactor, I run the tests. Everything should run now instead of the last one. Now I want to write the code that check that the time duration is passed. Let's do it. So I can do if, and I do like this: invocation. No, if clock dot instant dot to approximately minus invocation dot timestamp dot to approximately from duration window dot millis. Okay, so I know it's ugly and it's big. I'm going to factor it in a second, but if the time duration is passed, I want to remove from the map the key and return try acquire of a key. And let's do like this, and wait a second. Okay. So let's run the test and see if it works. Okay, but it's fairly ugly. I don't like this totally mess. I want to understand the semantics of what I did. So let's do some refactor, and I'm going to do something like refactor and extract a method. I call it expires, and in a Scala one-liner, I want to remove the carrier devices. I don't like them. Now it says expires of invocation. And let's run the test again. And see that I'm in green bar all the time, and I refactor in green bar. Everything green bar. Now I see this. It's also it's not code duplication, but it's something that like smell like I don't like it. I can also extract this one too. Let's say a new object, extract method. Sorry, extract. Wait a second. Sorry about this. Extract method. Extract method. New invocation. Okay, so new invocation. I'm going to also remove this one. Let's take it down. I did some reformat for my code. Let's run the code. Okay. Now more or less my test describes the behavior I want to get, but my code is not pretty. And I now want to do with you two refactor. Let's do the first one, and then we'll see how we can proceed. So I see that like I have if, else, if, and I see something like I see a pattern that I have expiration handler and I have a real throttling mechanism. I can define it into two something we call in Scala a partial function, and you can compose them. Let's give it a try, okay? So I'm going to create a set of computation functions. So let's do it. Val expiration handler. It's a partial function. You know partial function? Who knows partial function? Good. Okay. So for those who don't know, it's like partial function. It's like a function that runs on a condition. If condition is passed, then the function is running. You can compose them with or else, and you can do it. Function can go from string to invocation, and return a try of unit. So now I'm going to create this thing. So I'm going to do case. I'm going to extract the string and the invocation to key and invocation. And I'm going to ask if expires invocation only if this condition happen, this code will be running. So what we're going to do here, I'm going to invocations. I'm going to remove the key, and I'm going to return try acquire of a key. Sorry, yes. And let's right now create our main handler. So, sorry, val throttler handler. It's also partial function of a string to invocation to try of a unit equal this. Again, we have the same extraction of a key and invocation, and this comes no condition, and I do something like this. Invocation counter. Let's copy this code. Invocation counter increment and get max if count, no, if not count, if allow, so I do success, else failure, new exception. Okay, so now I have my two functions, and I want to remove this code. Okay, so I'm going to remove this code. I want to compose my functions. Okay, so I can do expression handler, or else, throttler handler. The partial function gets a tuple of string and invocation, so I can do like this: key, and arrow to invocation. So it's more descriptive code. I do this or do this. Let's run my code. Okay, it's running. I still don't like my code. I think it's verbose. I think I might get it more descriptive here, but I think don't like it. But before that, I want to do something else. I have generic exception. I want to get more meaningful exception. Okay? So let's do a failing test first. I want to fix my test. So this is fail try. I'm going to say I want with throttler exception. Let's create a function, create a class. Top level in this file, extend rebel. Okay. So I have my test running. It's red, but it's working. IntelliJ is not the best in Scala for everything. Let's run the test, and we might be fail. Now again, we are in a red bar. So let's fix it, and I'm going to do throttling exception. Okay. Now is the fun part. Now is my end of my talk, and I'm going to say, okay, I did so many things, but now I know what I should do. I think all I need here is a caching. So we're going to refactor everything and enter a Guayava cache. You know Guayava? You know Guayava? So let's remove all the code and rewrite it again and see if it works. Okay, so I'm going to do like this, and val invocation, it's a cache, loading cache. From string to counter equal cache builder. A second. Builder dot new builder dot build. Build get a default cache loader, so I can have default cache object. Let's get help, create method. I'm gonna do it from string to counter, and I'm gonna do new cache loader from string to counter. And it's ready. I need to implement a function, so let's do implement of the method. It's just return a counter. Okay. Now I have an invocation running. I'm going to remove this code. Invocations dot get of a key dot increment and get max val allow equal. We're going to remove also this one. If allow, I'm going to do success. Success. Else, I'm going to do failure of throttling exception. New throttling. Okay. I can remove all this code. I don't care about it. I can remove this. I don't care about this. I don't care about the invocation. Okay. Do you think it should work? Do you think it should work? This will work or not? Okay, good. Because we didn't take care of the expiration, let's run the tests and see what's going on. Okay. So I didn't care about the expiration. So let's now add some functionality to the cache. So I can do some expires after write. It's get a long and a time unit. So I can do after write. It's duration window dot millis, and it's time unit dot millisecond. Do you think it's gonna work? Okay, you're right. I didn't provide a ticker, so let's run it again. It's not work. Now let's provide a ticker. A ticker is made. I will give a clock to this a ticker. Throttling ticker. And let's create method throttling ticker. I'm going to help with this. Add new ticker. Okay, now it's already long. I know that this must be a nanosecond. So I'm going to do something like this. Time unit dot millisecond dot 2 nanos. Clock dot instant to approach milli. Now it's going to work. I hope. And I want I want to remove these two functions. In a clean code, it says a class is like a story. The first important thing is in the app, then you go down, and less important thing, let's remove this function downs. Okay. Again, I don't like this code. I want to do some cleanup. I want to show you some trick. It's called implicit conversion in Scala. You know implicit conversion? Who knows implicit? You know? So I can do some code that make it more concise. In Wix you don't like implicit conversion, but I'm going to do it anyway just to show you and show that I make it more concise. So let's do like implicit def boolean to try, which get boolean and return a try of a unit, equal if b success, else failure, new throttling exception. Instead of doing this, I can just return this and remove all this code. You see that this line, you have a line on this code, everything is green now. I want to remove it also down because I don't care about this much. Okay. Let's run this code. Okay, so now I have very clean code. I want to reformat my code again. And we're almost done. And now I want to extract my production code to the production place on my code. So I'm going to...
IP address of people who violated our window in the exception. So it's not just a throttle exception.
Yes, I agree. I just didn't have time to do it, but I agree. Yes, we can do add more information to the exception. Yes, I agree. Okay, so now I want to move this to production code, to the production place. So I just put here, I put F6, and I move it to the production code. And this, and I want to move the counter, F6. Also the exception. I know the exception is not descriptive, but just for the sake of simplicity. Okay, one last thing I need to do. You see, I have, because I wrote the production code is in the test, I have some unused imports, so I'm going to do optimize imports. IntelliJ is helping me doing it. I'm going to run the test again. And this is it. This is how we code in Wix. We came from the usage. We write the code from perspective of what I need to do. Then we implement the changes. The idea of clean code and everything, it's like if another developer coming after me, I don't care, no fear. You can change, you can refactor. If you read Uncle Bob Goose, you know this book of Nat Price, Goose? Growing object-oriented software guided by test. So he's presenting code like a flower, which you need to water all the time, like a plant. So if I do such of code, everyone comes. It's a Boy Scout rule. Every time you come to a place, you need to put it clear that you come into it before. So if we're doing such code, it will help us in Wix and help us be less fearless and help other guys that see a code smell and something to do some refactor. Questions? No questions?
Thank you for the talk. Yeah.
Thank you. Okay.
Okay, but thanks for sharing experience. The question, well, how does the unit we wrote integrate with the system that sends the requests to database and so on. Just, you know, I don't ask for showing some modules that do the actual interaction, just, you know, interface that we bind to this rolling window class.
Yes,
So,
okay,
yeah,
so it's a good question. I didn't have time to create the application. The idea is that you have already running an application like the quiz server. All you want to test in this case is the wiring of this library. So you do only one test of like from the outside doing 2 requests for the same IP, and you should get auto exception. You don't test everything, you just test the connection. And once you do it, you okay, and that's it. Okay.
So I mean, it's another story, yeah. So the
Yes.
connection.
For the next talk, I'm going to also create a sample project of like a quiz server, and then I'm going to wire it up and show how it's going to wired.
Thanks.
And I'm sorry, I didn't, for simplicity of this talk, I didn't pay attention for concurrency, but just to show you how to do the clean code in TDD. Okay. More questions? Okay, thank you. Now we're going to ask Tomer to join, replace me.
Or maybe we just take a break.
Oh, okay.
Get pizza, beer, and
Okay.
after that, well, we have 10 minutes, I guess. To Tomer. As Tomer said.
Okay.
Yeah, but I should move away from the thing. Rust. Yep. Okay, I guess we're good to go.
Okay, so the second talk is going to be given by Tomer, and he will talk about, everyone knows that Java 8 finally got lambdas, but Tomer will show us that the Scala still has a lot of stuff that Java 8 doesn't have, and probably will never have. So please welcome Tomer.
Light. Oh, okay. That's good enough, I guess. Okay. Hi. Is this reasonable? Isn't this a little bit loud? Should we? No. Okay. Hi. So my name is Tomo. I work for Wix in Israel, which means that I'm gonna bore you to tears with my strange accent. This is going to be a talk about Java 8 and contrasting it with Scala a little bit. So I want to apologize in advance. I'm not nearly as ready with the material as I usually am. So it's going to be a bit ad hoc. Then again, we're a small group. So like if something does not make sense or you want to dive a little bit deeper, I'm in no hurry. So, you know, raise your hand, ask questions. We can take this in any direction that you like. Don't be shy, you know. So if it seems like I'm talking out of my ass, call me up on it, and we'll figure it out from there. So, a little bit of preface. Java 8 is, what is it now, like almost a couple of years old. It's in production, it's production grade. Everyone more or less uses it, I hope. Which begs the question, you know, is Scala still relevant? Now that Java 8 is out, it adds a bunch of features. It seems to reduce a lot of the gap, a lot of the advantages that Scala used to have compared to Java 8 seem to have gone away, or at least they seem to have gone away. So the question is Scala still relevant? And the answer, as far as I'm concerned, is an emphatic yes. So what I'm going to be doing for the next, 45, 16 minutes, however long it takes, is to try and convince you that Scala has a great deal to offer, even though Java 8 compared to Java 7 is a huge step forward, but at the risk of hyperbole, it still sucks. Right, so quick agenda. What we're going to be doing is we're going to be covering just a tiny bit of history, right? We're going to be sort of analyzing the gap between Java and Scala historically. By history, I mean Java 7, which doesn't sound all that old, but Java 7 is like 6 years old now, right? It's pretty old. Java 8 reduced some of that gap. We're going to try and take a look at what things Java 8 adds to the mix that sort of reduce the advantages that Scala has. And then we're going to showcase a few techniques that you can employ in Scala and see how they can make your life a living hell. I mean better. Right, so historically speaking, right, Java 7, pre-Java 8 basically, because Java 7 isn't all that different from Java 6. Scala had, quite a few features that Java did not, but really the fundamental features that you would care about in Scala pre-Java 8 are these 6, right? So you have pervasive type inference, which saves you the trouble of having to type, types all the time. You had lambdas, you had traits, the collections library in Scala, you had DSLs and implicits. I'm not going to be touching on a lot of these, but just to give you a bit of context. So when Java 8 came out, obviously the really big feature of Java 8 is lambdas, and the corresponding feature of Java 8 is the streams collections API. So these are kind of the two big things. There's a whole host of I'm not going to be talking about the class library. And the reason I'm not going to be doing that is because if you're on Scala, you're enjoying everything that the class library has to offer. So all of the advantages that Java 8 has in terms of the classes and features that it offers in the library are also accessible through Scala. So it's not really an advantage there. So Java 8 covers the gap a little bit, and it removes ostensibly 3 things, right? It deals with lambdas, so that's no longer an advantage Scala has. It adds the stream collection API, which, it has its ups and downs, but basically it's comparable to what Scala offers. It's comparable to what Guyava used to offer. It's comparable to what what's it called? I can't recall, the weird collection library that you used to have for Java that is not Guava also offers. So that's one thing that we can take off the table. So one other thing that it adds are default method implementations and interfaces. And ostensibly, by which I mean people say it is known that almost gives you Scala traits in Java. That is bullshit, but we'll cover that in a bit. So we're down to those three fundamental advantages that Scala has over Java, which is type inference, DSLs, and implicits. Type inference, I'm not going to talk about because it's kind of obvious. DSLs, I'm not going to be talking about because it's kind of boring. We're going to be touching implicits a little bit, but there's, one of the funny things about Scala is, these are like the 6 fundamental differences, right? These are the 6 fundamental advantages Scala used to have. But actually, if you look at the feature set that Scala offers, you get all of these as well, right? All of these are things you do not get in Java. And I'm not going to be talking about any of them, right? It's just a list so that you can, get a sense of just how far more advanced Scala is compared to Java. With that in mind, why do you care, right? I mean, what does Scala offer you that you actually care about in your day-to-day work? So we're going to showcase 3 features of Scala, and we're going to try and show how they can improve your day-to-day lives as programmers and offer you things that you simply cannot get in Java without going into too many haywire details. I tried to pick sort of commonplace use cases, things that you would do, things that you would encounter in your day-to-day, not like esoteric stuff, not functional programming or any of that other shit, just things that you actually do that you can do better in Scala. So the first thing that we're going to cover are traits. And we're going to start with a sample bit of code, and this is Java, right? This is not even Java 8, this is Java 7 code. It doesn't really matter because you couldn't really improve it with Java 8 features. But, you have this class, it's called class with logs. It's got a private SLF4J logger. And you have this really, really stupid algorithm that takes a name and normalizes it, whatever that means, right? In this case, normalizing a name basically means taking a person object, getting its name, uppercasing it, trimming it, right? It's a fake, completely artificial use case, but it just goes to exemplify what logging is like in Java. So there are 2 things wrong with this bit of code. And this is really simple code. So anyone care to take a guess what 2 things I'm aiming at, what I'm going to point out here? No, it's not a trick question. I mean, there might even be bugs here. I don't care. That's not the point, right? Things that are fundamental to this code, and this is code that you would write like 100 times a week, right? I'm sorry? You can share the logger. That is true, but why would you want to? Do you ever share loggers when you work with log4j or slf4j or whatever? Yeah.
Like you are building string. You are creating string builders implicitly.
I'm creating string builders implicitly. Also true, but also not the point. So okay. So instead of bothering you with trivial guesses, let me point out what I mean by 2 things that are wrong with this code. You can use Scala string. Scala string is Java string. Scala doesn't have its own string type. Oh, yeah, you can use string interpolation, but this is Java code. Okay, so you're trying to find something smart, right? The answer that I'm looking for is not smart. There are 2 things that are wrong with this code. One is there's a ton of boilerplate here, right? If you're going to have 1,000 classes writing logs, and you will have 1,000 classes writing log in any meaningful kind of, especially server code base, right? You're going to be writing these imports and this private thing 1,000 times over. Now, I don't know if anyone here was around and remembers when slf4j sort of came onto the scene and started gaining traction. Basically, you had this exact code, but typically you would have something completely equivalent, but for Java util logging, or for log4j, or for logback, or whatever kind of logging backend you used to use. Right? This is boilerplate. This does not add anything to your code, right? This has nothing to do with the logic that you intend to write. This is just strings that you need to write, that you need to type in every single time, for every single class that does any logging in your code base, which is most of them. So boilerplate is an issue. The second issue is actually considerably more pervasive, and that's the fact that when you do these things, they're eagerly evaluated. So anyone who's written any sort of meaningful scale or meaningful performance server will know that typically if you, say, run into an HTTP request and you want to log some stuff about it, maybe you got a JSON object, maybe you want to dump the headers to the log or whatever at the debug level, right? Typically, your server in production will not run with debug logging enabled. So what this means is that you're serializing JSON objects and serializing strings and doing all that computation uselessly, right? So almost always with any Java code base, actually what you would have is not log.debug. You would have if log.isDebug enabled, then you write the logs, or as far as I'm concerned, even worse, you would use the format string capabilities of SLF4J or logback or whatever. And then your string starts containing these placeholders, and you might get the order wrong, and you won't see it until production, and then you enable debug logging, and then your server crashes because you screwed up something trivial that you never test because it's logging, right? So this is either eagerly evaluated or error prone. You don't want to do that, right? Ideally, what you would actually want to have, even in Java, if you could, which you can't, is something that looks more like this. Exact same code, except that instead of having all of that boilerplate and instead of using log dot, you just have this implements logging or extends logging or whatever, and then you get everything for free, right? Ideally, that is what you would want. So let's consider how to get there with Java, even Java 8. So we have two problems, boilerplate and eager evaluation that we want to turn lazy. So Java interfaces, even with Java 8, where you have default method implementations that seem to give you something akin to Scala traits. First thing is no state is allowed, right? You cannot have state in an interface by definition in Java. But you need a logger instance, right? If you want to write to a log, you need to have something that is, that wraps this. If you want to eliminate the boilerplate, something else needs to run through this code, right? So you need to carry state in your logging helper that actually provides the logger instance. But that is stateful, right? And you cannot in Java realistically have logging as an abstract class because that means you can't extend anything else. And logging is just a utility thing, right? You don't want to have to give up on the ability to inherit. What can you do about it? Well, not much really. I mean, there's really only two options. One is you compose a helper, right? You have a little bit less boilerplate where you do something like, private myLogging helper equals new myLogging helper this or something like that. Compositionally, that's ugly as sin. The other thing you can do is, with this kind of sample implementation, we have our public interface called logging. You have a method that is not implemented by the helper, but will have to be implemented by the class using the helper that provides a logger instance. And then you can have these nice kind of debug and info, etc. wrappers that do the checks on top of the logger and provide all of the nice utilities. This is problematic. And this is problematic really for two reasons. One, it adds boilerplate. That means that everyone inheriting from your logging, implementing your logging interface will actually have to add a tiny bit of boilerplate that essentially is the same as the boilerplate we're trying to eliminate in the first place, right? Because they would have to go to the log manager or logger factory, whatever, and get an instance of logger to provide to your helper. So you haven't actually saved anything. Furthermore, there's a much bigger problem actually, because in Java, interfaces only support public methods, right? You cannot have private or protected methods in a Java interface by design. The Java language specification will not allow you to do that. So that means that if you go this route, your entire logging API is visible to the consumers of your own class. So you cannot actually encapsulate implementation details, right? You need to expose them, or you need to suck it up and deal with all the boilerplate and the mess. Also, the logger itself is visible, which on the one hand lets you share it, but on the other hand, why would you? So, you know, you don't want to, you can't really use this solution realistically. So what about lazy evaluation? Right, you can kind of implement lazy evaluation with Lambda. So in Java 8, you have you know, a bunch of functional interfaces. One of them is called supplier. Supplier is just an interface with a single method called get that returns a value of some type t. So in our case, instead of taking in a string that is the logging message, we've taken a supplier of a string that gives us the message, that lazily computes the message on demand. So this actually does give us something akin to lazy evaluation. Now, this is actually a reasonably workable solution. You couldn't do that in Java 7. If you tried to do something similar in Java 7, your logging code would be a mess because you would need an anonymous inner class for every single log message, which is insane. In Java 8, it looks a tiny bit better. It's still ugly, right? You still need this Lambda syntax, right? The empty parameter list to the whatever it is that generates the string. But this is, you know, this is starting to look like something we might be able to work with. Conversely, right? So this is Java. This is the best we can do in Java. In Scala, you have something called traits. And a lot of people assume that traits, like, the easiest way to think of a trait is as a partially implemented interface, which, you know, Java has, right? It gives you default method implementations. Except there are several differences. So to begin with, in Java terms, a default method implementation is basically just a sugar, right? It's a static method somewhere that implements the default behavior. And you can override it because it's an interface, but you cannot actually override it in an inheriting interface. There are a lot of limitations around that. Scala traits are first-class citizens in Scala. So they allow you to have state. They have a life cycle, right? A Scala trait has an initializer block, and it enjoys everything that has to do with scoping, right? It comes into scope, it gets initialized. It goes out of scope, it gets destroyed. Same thing as any other kind of first-class Java or Scala type that you're used to, except it's abstract. It doesn't have a runtime representation. You cannot instantiate a trait. You can take a trait, and if it has no abstract members, you can make it concrete in an anonymous way and make it look as if you're instantiating the trait. But in fact, the trait is completely abstract, right? It doesn't have a life of its own. It needs to be mixed into some class. It supports visibility. All of the visibility modifiers, you can have private members, protected members. Scala actually has a bit richer visibility modifier ecosystem than Java has. Right, Java basically gives you package protected, private, or public. In Scala, you can actually scope things depending on the package. Like you can say, okay, this thing is scoped to, like if it's com.wix.sample, right? You can scope it to just sample or just com.wix or com entirely, and you can have all of the usual niceties that you get in Java. So an and also, and this is something I'm not actually gonna touch on in too much detail, but traits essentially give you type-safe multiple inheritance that actually deals with the classic diamond problem in a pretty sensible way. So this is a form of multiple inheritance. You can inherit behavior, you can inherit state, you can mix, you can control the life cycle and the initialization order of everything that composes a single class. It's pretty damn powerful. But sticking with this example, right, this is pretty sensible. You have your trait, it's called logging. It has a private member called logger, which is the same as what we had in Java. You have protected helpers called warn and debug and info and all of that stuff. And I didn't want to focus on it too much, but this little arrow here, right, the message parameter is not of type string. It's of type arrow of string. So this is called by name parameters in Scala, and it essentially gives you lazily evaluated parameters that look just like any other parameter. So in practice, let me switch to IntelliJ for a sec, show you an example. right? We have our logging sample. This is an actual sample class, right? I wrote a whole bunch of sample code for this talk and ended up not using a lot of it, so don't go into the details too much. What we have here is an application object, basically a console object. The fact that it extends app just means that it gives you, the body of the object is essentially your main function. And it extends logging. And it does a bunch of stuff, but the punchline here is that we have here a call to debug, right? The thing that is selected is a call to debug, and it looks just like any other method call, right? There is no specialized syntax that says this parameter gets lazily evaluated. You don't have to have lambda syntax or anything of the sort. It's all determined from the signature of the method that I'm calling, right? So this essentially gives you everything for free, right? We wanted to have something that looks exactly like our older logging code, except that it's lazily evaluated and that it doesn't have boilerplate. So you can get that with traits, whereas you simply cannot get that with even with Java 8, right? You can come a little bit closer compared to Java 7, but that's about it. By the way, the Lambda solution in Java 8 is, in my opinion, still preferable to the formatting string option that people, for some reason, seem to love to use, because it won't allow you to fuck up, right? If you have an expression where you generate a string, it's going to generate that string. You cannot get it wrong. You cannot miss a placeholder or feed in too many or too few parameters or parameters of wrong types or whatever it is that you might end up doing in production. So that's still a preferable solution, even if you're not going the Scala route. Sorry. Okay, any questions?
I have a question. Are there any places where these by name parameters just give you what you don't expect? So, for example, if you pass something that you are expecting to be evaluated and that is not evaluated at all.
So as with any semantics, there are, you can paint yourself into a corner, right? So two examples that I can think of, two things that you might need to kind of be aware of if you're using by name parameters is if the actual expression that you're passing has side effects and you're relying on those side effects being actually applied at runtime, then obviously if it does not get evaluated, the side effect does not happen. If you rely on it, then you will have screwed up your execution. You shouldn't be doing that, generally speaking, like side effect in code. Okay, let me give you a different example. Those minus minus or plus plus operators that do increment and get, or get and increment. There is a very good reason why almost every modern language, by which I mean every language from, say, 2000 up, does not have these, because they're incredibly easy to abuse, right? You can save a line of code and in your for loop, for instance, do an iteration and a compare in the same expression. It's hard to reason about. It's hard to track. It's very error-prone, and you're basically relying on a side effect of an expression to affect the state of the universe in your application. So you shouldn't be doing that anyway, right? So that is one kind of something that you can get wrong. The other thing is a by name parameter essentially behind the scenes gets translated to what is essentially a lambda, like an anonymous function. And that means that if you evaluate it multiple times in your function, it will get evaluated multiple times, right? So if you're assuming that, once again, it all has to do with side effects, right? If your expression has a side effect that is not idempotent and you evaluate it twice, you might corrupt your application state. But once again, you should not be doing that. So in practice, I don't think I ever ran into a situation where this by name behavior surprised me as an end user. Right? You can paint yourself into a corner, but you'd have to work hard and do really, really stupid things to get there. Any other questions? Right. So that is one very, very trivial and very specific example of where traits are useful and the power they give you that you simply cannot get with Java 7. Right? There is a world of patterns that have to do with traits and trait composition, and it's incredibly powerful. I just didn't want to, I don't want to overload you with different use cases for the same feature. This is just one example of something you cannot do with Java, and you will never be able to do with Java as it is today. Right? You simply can't get it. Sorry. Right. Feature number 2, pattern matching. Pattern matching is one of the nicest things about Scala because it's such an easy sales pitch. Let's talk about the switch statement in Java or in C or in pretty much any non-incredibly modern language. So switch statements are incredibly limited, right? You cannot do much with them. They only support primitives. In Java 6, I think, they added support for strings. And that's kind of it, right? You cannot switch on anything else. You cannot have any kind of logic in your case statements for a switch, right? You cannot say something like, if whatever it is, like if I'm switching on a parameter and it's a string and it has the value, I don't know, I'm switching on a URL scheme, right? And I'm asking, if it's HTTPS, do whatever it is that's in this case statement, but if and only if my configuration parameter that is completely external to the switch statement says that I support SSL, right? You cannot do that. You need to implement this on your own. So you cannot have arbitrary expressions. You cannot have guards. You cannot have any kind of sensible logic in your case statements. You just, you're limited. There's nothing you can do about it. And also, the switch statement is, as the name implies, a statement. Right? So it has no return value. It has no result. Right? You cannot take a switch statement and assign it to a variable or feed it to return it from a function or feed it to as a parameter to a function. Right? It's literally a statement. So that's just incredibly limited. And the workarounds are ugly because if you do want to have those control structures, if you do want to say something like, okay, if the URL scheme is HTTP, HTTPS, for instance, then if I support SSL, do this, and if not, then throw an exception. Right? You need to do this manually, which is kind of annoying. And also, because switch is so limited in terms of what it can actually operate on, that means that if you, for instance, want to switch on not the value of a thing, but the type of a thing, right? You get in a message. You have this generic application platform, whatever, and it accepts a number of different types, and you want to say, okay, is this of type message 1 or message 2 or message 5, and do different things, right? Do a dispatch based on that message. Right now, you cannot do that with a switch statement. So you have two options. You either do an if is instance of, else if is instance of, else, etc., or what you commonly do is you encode the type of the message as an enum. Right? And you have that enum in your class, and you switch on that instead of directly on the message that you're getting. So that's pretty limited. Conversely, in Scala, and actually in a lot of modern languages, right? You get it in Swift and in Rust and pretty much any kind of postmodernistic programming language. There's support for a lot of different things. So first of all, when you pattern match in Scala, like essentially the equivalent of Scala of a switch statement can operate on any type. It supports guards, by which I mean if statements. It can check for exhaustiveness, which is something that I hope to be able to demonstrate in a bit. It's user extensible and it's ubiquitous. And I'm gonna try and showcase a few of these things in a bit. So, are you ready for code? Okay. I hope I don't embarrass myself too badly because I wrote this at 5 a.m. on a plane. Right. Switching to my favorite IDE, which is IntelliJ. Right. There's a few examples here. I have, to be fair, written them in Java as well. And you will see that for the very simple cases, the Java code that is equivalent is not actually that horrible. But I hope you will get an idea of the kind of power that you get with pattern matching. So the first example is command line parsing. right? If you write a command line tool, so in this case, what we have is something that that essentially implements the head command line utility from the GNU toolchain, right? The thing that you get with any Unix, right? It takes a file, you give it a number of lines, and it just dumps the first however many lines of text in that file. So really, in this case, what I want to do is I want to say, okay, I get a bunch of arguments in my command line, and I want to be able to say, you know, I want to have three cases. One case is I got no parameters. So what happens if you run tail or head with no parameters, right? It reads from the standard input, and it outputs a default number of lines, and then it quits, right? So there's a default behavior. Conversely, if you give it a file, then it has a default number of lines, but it's going to read from that file, not from standard output. And the last thing is, if you give it both, then obviously it does what... Sorry? I suppose I could. Command what? Command Shift A. I'm gonna do this instead. Right, presentation mode. Brilliant. First time I've ever used it. Okay, so this is Scala code. So if it's pretty simple Scala code, but I mean if it's confusing to anyone, then just point it out and I'll try to explain it as best I can. What we have here is, first of all, for those of you who have never seen Scala before, an object in Scala is a singleton, right? Scala has first-class singletons, so you don't have to have a static class with a static field that is the instance with the double-check blocking pattern to get the instance and all of that shit, right? You just call it object and you get it for free. So I have pattern matching 1, which is an object. It extends app because it's a console application, so the body of the object is the actual running application. It has this constant called default line count, as the name implies. The default is 10, as with head or tail in Unix, I think. And what I want to say is, I want to read in the command line and get two things out of it. I want to get an in, or rather, a file input stream that represents my input file, and I want to get the number of lines that is desirable. And what I do is, let me just insert a bunch of white space here so it's easier to focus. Right. I have several cases. In the first case, I'm looking at args, and args is exactly the same as in public static void main that gets an array of strings, right? Exactly the same. So args is literally, oh wow, there's a lot of output here, right? What you should care about is this. Args is an array of string. And now I can pattern match on it. And what I say here is, if it's an array, and this thing takes, you know, takes basically any number of parameters, and it matches against the contents of the array. So what I'm saying here is, if it's an empty array, what I'm returning is a tuple of system.in, same as in Java, and default line count. Right? So that means I'm reading from the standard input, 10 lines by default. If I'm getting one parameter, right? If it's an array with one parameter, I give it a name. This is called the binding, right? I bind the value of the first and only element in that array to something called inPath that I can then actually use from my code. And then I return a tuple of file input stream based on inPath and the default line count again. In the third case, I get two parameters, and I give them the names inPath and line_str, and then once again I create a tuple of the file input stream from inPath, and I parse the line strings to an integer. Right? So this is, you know, this is a really brain-dead example, right? This is not intended to challenge you in how amazing and complicated this code is, right? It's intended to showcase how powerful pattern matching is, and this is literally the simplest case of pattern matching you will run into. You can do insane things with pattern matching. And also, as always, there's the default case, right? So if I got, you know, 3 parameters or 50 parameters, I would probably want to show a usage of some sort and just exit. So that's exactly what I'm doing here. The details don't matter, right? It's just a default case. Any questions regarding this example?
Could you explain, please, what does mean S before stream?
Oh, this. All right, this is a newish Scala feature from 2.11. It's string interpolation. So if you've ever written code in Ruby or Python or PHP or whatever, you know that when you use double quotes for a string, then you can inject variables into that string, and they just get rendered into the string. So it's the same concept, right? This is actually a pretty nice feature, and it's very user extensible and blah blah blah. But you don't really care about the details. The fact of the matter is, and this is actually shown in IntelliJ, right? Green is a string, and then once you prefix it with a $sign, then this is an actual Scala expression that can be anything, right? And it just gets interpolated into the string. Okay, any other questions? Cool. So this is a brain-dead example. Like I said, it's not intended to be anything beyond a primer. So let's look at a second example. I did mention, oops, sorry, this is the Java version. I did mention that, that pattern matching is user extensible, right? So what I meant by user extensible is that you can do a lot of really interesting things with pattern matching. One example is you can pattern match based on a regular expression. So we have here a naive and pretty stupid and not really workable regular expression that represents a URL, right? So for those of you who don't fluently read regular expressions, this is one or more letters, and I group them, right? I want to be able to extract that from a matching string. The colon sign, // either a lowercase letter, an uppercase letter, an alpha, and basically an alphanumeric or a dot or a dash, one or more of these, and then that's followed by potentially one or more slashes. So it's basically just a very rudimentary URL parser in a regular expression. It's not intended. This is not the point, right? Don't read too much into it. The point here is I have the string, right? I take the first parameter from the command line, and I can match on it. And this is where it gets interesting. I can use this URL that I created to pattern match. And I give the different groups, the different matching groups extracted from the regular expression, I can bind them to names during the pattern match and just use them as is. Right, so in Java, the same code is really not terrible at all, right? But it would look kind of like this, right? I have this URL pattern, same regular expression. I compile it through pattern compile. I create a matcher for it. If it matches, I bind, right? I create local variables with the corresponding names, and I extract it from the matching groups, right? So this isn't bad, right? This is sensible code. You can read it, makes sense. But this does two things. First of all, it's a lot shorter, right? And you can reuse this. You don't, like, if you match URLs 1,000 times, you can use the same pattern match, and you don't even need a helper function to help you do that. You can just pattern match anywhere based on this URL pattern. The second thing is it's a lot more condensed, right? It's a lot shorter. It's a lot easier to understand, which is nice. And the third thing that it does is it exemplifies just how powerful it is when you can actually extend the pattern matching on your own, right? And you can actually do that. And I'm going to show you one example of how to do that. So, looking at the third example, pattern matching in Scala. What I have here is an extension of the same concept. I have here the same URL pattern. And what I'm doing here is I'm basically creating what in Scala is called an extractor object. An extractor object is basically a regular Scala object that has a function called onApply, and that's by convention, right? That's just what it's called, doesn't really matter. It takes in a URL, and it outputs optionally, because it may or may not be able to pattern match, right? The pattern match may fail for this particular extractor, but it doesn't mean that an exception gets thrown. It just means that it did not match, right? So optionally, I output a tuple of two strings and a boolean. And what these two strings and a boolean are is I can recursively pattern match. I take in the URL, I match on it. If it's a URL with, and here I'm not actually binding to anything. Here I'm providing a concrete value. So what this means is I'm pattern matching on URLs where the scheme is the string HTTP, right? This code, this thing, will only happen if the string that I was given matched the regular expression, and the first matching group, the first capture group from the regular expression has the value HTTP, right? So if it's HTTP, I extract the host and the path, and I give back the host, the path, and a false. What does this false represent? I'll show you in a second. It'll become very obvious. I have a second pattern, a second case statement here, right? If I get a URL with HTTPS as the scheme, I output a tuple with the host, the path, and true. So the Boolean value in this case actually represents a true or false of whether or not the URL is secure, whether it's SSL enabled, right? So this is my decision. This is just sample code, right? It may or may not make sense for you to do that, but you can, and that's really, really powerful. I have a second extract. Oh, and in any other case, I return none because I did not match. With FTP, it's the same concept, right? I have an extractor object for FTP URLs, and it shows case URL. If the scheme is FTP, I extract the host, I extract the path, and I give a tuple of host and path. And then I can just freely use these, right? So I take in the first command line argument. If it's an HTTP URL, I can print line that it's an HTTP URL. If it's an HTTP URL with true for the Boolean value returned from the tuple, I don't actually give it a name because I don't care. I want to say this thing only happens if the value of this thing is false, right? I don't need the name for it. Conversely, if it's true, I want this case. Or if it's an FTP URL, I can have a different case for it. Now, the nice thing about pattern matching, beyond the fact that it's very, very flexible and you can do a lot of different things with it, is because it has so much power in terms of the expressivity that it gives you, you don't need weird control structures, right? Anyone who has, right, for some of you, this might be the first time you've actually seen any amount of Scala code, right? So this might seem a little bit confusing. But if you've been working with Scala for more than, say, a week, this code is completely trivial. You will see it all the time, everywhere. You don't have to think about it. It's pretty, it's obvious. And then when you read the code and you say, okay, what does this code do? You say, okay, well, I'm matching on a string. If it's this, then it's this. You don't have to, unlike with a switch statement where you have to actually have control structures embedded in the different cases, you don't have to keep a state map in your head that says, at this point in the code, the scheme was HTTP, and I already checked if I'm secure, and did I do that? You don't have to keep that state in your head, because it's all written here very, very clearly. If it's an HTTP URL, and it's insecure, then this happens. Right? So it makes tracking the code mentally, when you're maintaining it 5 minutes, or 6 months, or 6 years later, just a hell of a lot easier, because everything you need to know about that code path is right there in front of you. Right, so this is immensely powerful. One other thing that I want to show you is I could do, like instead of these two things, completely equivalently, I could do this. If it's an HTTP URL, and you can see that because it's a statically typed language, IntelliJ gives me a lot of information about the parameters and the types that are involved. I give it the name host and the name path. I didn't, by the way, have to use a tuple. I could have used a proper class, and you can actually deconstruct case classes just fine. So that's also a very powerful feature. And suppose I wanted to, for whatever reason, give it a name. Let's call it is secure. And I wanted to say, okay, this only happens if it's not secure, or if if is secure, and my configuration has a Boolean value called support SSL that might be true, might be false. I can actually have this guard, that's what it's called, this kind of embedded if expression here in this case. Right, so this is just powerful. You can do a lot of different things with it, and this is a very simple example. You can go totally batshit crazy with it. right? You can do pattern matching on top of abstract syntax trees that the compiler generated for you at compile time. Why you would want to do that? Well, maybe you're psychotic, I don't know, but you can do that. And that gives you a lot of power and expressivity on top of what Java gives you. So, that's mostly what I have for pattern matching. Any questions? Pavel, what a surprise. Do you have a question? Hold on a sec. Wait for it.
Sure.
Okay, go.
Okay. So I want to ask, how does pattern matching actually applies to existing objects like the regex? So
Any
Java
object.
can't implement the unapply on the existing Java object, and Java regex class doesn't implement unapply.
So
does it have the
one thing you can do is, these are called extractor objects, and I actually call them objects because they're singletons. But in effect, any instance that you have that has a name and has an unapply method can be used for pattern matching. In fact, one example you can actually see here is URL. It's not an object, it's not a singleton, it's an instance that I generated, right? So what .r does, it uses Java regular expressions behind the scenes. It just wraps it with something that provides an unapply.
So it's a wrapper. Okay.
Yeah.
Okay.
So you can actually extend pretty much anything you want with extractors, and it gives you this very nice, very clean syntax that you can get at for just about any type of decomposition or conditional dispatch or whatever.
And for case classes, does it do the same thing, or
For
does it
case-
actually
for case
do
classes-
compile time optimization?
No, for case classes, the reason they're called case classes is because you can use them in case statements. So that's actually exactly what they're there for. You can literally, hold on a sec, let me increase the font size here. Okay, I have Scala REPL running. Actually, Java 9 will also be coming with a REPL because they've learned, The people behind Java, okay, let me be very clear here. Java is a very smart language, and it's very well implemented. Okay, there's a lot of good things to say about Java, including Java 8. In fact, the Lambda implementation for Java 8 is a case study in amazing design, right? That being said, they have backwards compatibility to deal with, so they're a lot more limited, right? But they do learn, they do improve, right? It's not a bad language. It's just that you can get better, so if you don't need the backwards compatibility, you can enjoy the benefits of a more modern language. Let me define here a case class called person. Give it a name, give it an age, right? Stupid. Now, let's say I want to have a method called greet, takes in a person, and returns a string. And let's say that my greeting will depend on the age of that person. So if, for instance, I get in a person with a name and an age, and I want the greeting to depend on whether or not the person is an adult. So I can do case person, break it down into a name and an age, right? I don't even have to use P anymore in this code. And I can actually do if age is under 18, let's say it's hi boyo, and conversely if it's an adult, I will say, I could actually, by the way, ignore this if statement because, obviously if it's not going to match on the first case, it's going to match on the second one, right? So I can just forget the if, but I like to be complete with these things. Here it's hello, Mr. Presumably. Apologies to the ladies in the audience. It's just I'm lazy. Hello, Mr. Name. Right? I can do that. I can literally decompose a case class as much as I want. Right. Before we move on, one more feature, and a very awesome feature of pattern matching that I want to show you is exhaustiveness check, because this is another huge selling point. So in Scala, generally you do not use enumerations as you would in Java, right? There's no enum type as such in Scala. What you would do instead is say something like, say I have a gender, right? And it's enumeration. It's male, female, and alien and other, right? Because that's what I feel like. You will notice that I wrote sealed trait gender, and that will make sense in a second. It has no members, no nothing. I don't care. It's just a marker trait. And I have a case object male extends gender. Case object female extends gender. Case object Kfir extends gender. Right? And now I have def is weird takes in a gender. And I want to say for any case of gender, I want to decide whether or not it's weird. Right? So I do. By the way, full disclosure, this may not work because it's in the REPL. The REPL has a few caveats of its own, but it should do what it is I intend to do. Oh yeah, this is not a lambda. If it's male, then probably weird. If it's Kfir, definitely weird. Do you see this? The compiler took a look at my at my various cases. It determined that I did not deal with every conceivable case, and it issued a compile warning. Right, so I get exhaustiveness check from the compiler. And the reason the compiler can do that is because it knows all of the cases. And the reason that it knows all of the cases is because I use a sealed trait. A sealed trait, sealed in Scala means that every conceivable subclass of whatever it is I'm defining has to be in the same compilation unit, basically in the same file. Right? The reason why this is important is because if it's not sealed, then anyone can add cases. Right? There is no way to do an exhaustiveness check. But in this case, it gave me a warning. So what would happen if I do is weird female? What would you expect to happen? Some sort of exception, runtime error, right? If it were C or C++, you'd get undefined behavior, and your application would blow up along with your bank account. But in this case, you get a match error. Right? So the compiler knows enough to warn you, and at runtime it throws an exception. This is incredibly powerful, because if you have enumerations and you forgot to deal with a case in Java or in C or in C++ or any other language that you're used to, nothing will warn you. Right? You're going to have to write a whole gamut of tests just to make sure that you did not fuck up your pattern match. Here, you get the compiler on your side, which is incredibly powerful. Right. This is it for pattern matching. Any questions? Right. Last thing I want to show you, and this is also a bit hard to explain, but also incredibly powerful. So I'm going to need some more. I'm going to need a lot more booze for this, evidently. Crap. Is anyone taking the time? How much time do I have? Was that a whatever? Yeah. Okay. Right. I still have like a bit. Right. So implicits. And the reason why I chose this picture is implicits are kind of a mystery to non-Scala developers. It's not actually that hard a feature to understand. I'm not actually going to deep dive into the feature. I just want to show you one of the really, really cool things you can do with it, and that's called type classes. So to set the stage, right, to give you some context that you will have probably run into at some point, and you probably already know. Serialization, right? Serialization is something that everyone deals with, right? You have your domain objects, you serialize to and from JSON, and if you're writing in Java, more likely than not, you're using Jackson for it, because that's kind of the go-to standard, the golden standard in the Java ecosystem. So, what is serialization? Really, it's a three-step process. The first thing you do is you have your domain object, right? You have your person class or whatnot. The first thing you do is you do reflection, right? And by reflection, I don't mean runtime reflection. What I mean is you have a type. You need to reflect on that type. You need to figure out the structure of that type. You need to break it down into components, right? So if it's beans, you have your property getters. If it's something else, then you do runtime reflection and you figure out what are the publicly accessible fields that are not marked with @JSON_ignore. Whatever. There is some mechanism that is intended to take your type and break it down into its components. That is the first thing you do. The second thing you do is you do dispatch. right? If you want to serialize or deserialize, you need to iterate over your components, and based on each component's type, you need to dispatch the correct serializer, right? So with Jackson, for instance, if you have your custom type or custom serializer, you register a module with Jackson. There are a number of ways you can do that, but basically what it means is when Jackson runs into your custom type that you've registered with your object mapper, it knows to dispatch the serialization or the deserialization to your custom module or builder or whatever, right? So it's a dispatch process. And then the result gets aggregated, and that's your serialized result. And then there's profit, right? If you've managed to serialize your object correctly, your bank account will increase, the world will be saved, and you will have nice and fluffy kittens to pet, right? So that is the desirable end goal, kittens. So how does that tie in? Jackson uses runtime reflection, and runtime reflection is shit. And the reason why runtime reflection is shit is, well, there's a number of reasons, right? But mostly, it's really, really hard to predict what the behavior of the serialization is going to be ahead of time, right? You look at your class, you feed it into Jackson. Do you know what the result is going to be like? Not really. You need to test, right? It's really, really hard. It's not consistent. It's not trivial to understand what the result will be. And it's lossy. So if you have, if you have generics, if you have maps and options and all sorts of interesting stuff in your domain model, you're going to have to jump through a bunch of hoops to figure out how to deal with them properly, because in Java, generics get erased, and therefore Jackson does not have the relevant type information to decide for you. So you need to give it hints, and you need to, find various ways around it. Also, Jackson is pluggable via modules. So what this means is if you're, suppose you have a person class, right, and it has a field called address. And address is a bit wonky. It needs to be serialized in a special way, I don't know what, right? You need to have a module or a builder or something registered with Jackson to deal with that. If you forgot to do that, the result is completely undefined. Maybe you'll do runtime reflection and figure out something that approximates what you wanted. Maybe you'll throw an exception at runtime that it doesn't know how to deal with your type, right? So it's easy to forget the setup that you need to do to get the result that you want, and therefore, as with anything that happens in runtime, right? The reason why you need testing in most dynamic languages, as opposed to want testing, as you would typically in Java, is because you need to check a lot of trivial cases. Right? The only way you can ascertain that the object that you're serializing generates the correct JSON or reads in the correct JSON is if you've tested it. If you haven't tested it, it's probably going to break at runtime, and you're going to get a call from your boss at 3 a.m. and a pink slip in the mail the next day. Right? So that is undesirable. That is why you write tests. So it's really, really easy to forget, and it's really, really hard, not hard, but really time-consuming and annoying to have to test manually. So there's got to be a better way, and there is. In Scala, you have something called implicit parameters. Sorry about that. Let me just shut this thing up. Right. In Scala, there is something called implicit parameters. I'm not gonna bother you with the details too much, because if you're interested, you can read into them. But suffice to say that implicit parameters are method parameters that get filled in by the compiler. And the way the compiler does this is based on the type. Right? So the compiler has a certain search scope, right? It knows where to look for things that are available of a certain type. Right? So if you have an implicit parameter of type, I don't know, right, type person, and something is available in the search scope that is of type person, that is what the compiler will stick in. These are not parameters that you typically do or even should explicitly specify. Right? The intention of implicits is to ask the compiler to provide it for you. One way, slightly incorrect way, but it's a good analogy to think about it, is compile time dependency injection. Right? The details are not that important. What is important is that there are well-defined rules for that, so it's not like magic. Right? There are very clear rules of where the compiler looks for what. But the punchline of it is that it allows you to define something called type classes. So here we have a trait, and you have something very similar in Jackson. It's just that the wiring all happens at runtime via modules, right? This is a serializer for type T. Okay, and in this example we're talking about JSON, so really there's two methods here, right? This is something that deals with JSON serialization for a certain type T, and it serializes a value of T, returns a JSON value, right? And in memory JSON AST representation of the serialized instance of T, and you have a deserialized. It takes in a JSON value and it tries to deserialize a T. Now it's possible that you fed it in wrong information, or you just got a malformed JSON over the wire, so deserialization may fail. That is why it returns a try of T, and I think Phil mentioned try in his talk, so it should not be too foreign to you at this point, right? This is just the concept of what is a serializer. Any questions on that before I start to make sense of it? Right. Sorry? Okay. So we have this something called type class that is a serializer of T. Now, the thing about type class, the thing about implicit parameters is that the compiler resolves them recursively. So what this means is, in practice in Scala, you can encode dependencies, right? So if you have a serializer of type T, you can always handle the serialization of an option of T, right? Because you delegate, you don't need to know how T gets serialized to handle options. You just know that you either do not emit a JSON field, or maybe you emit a null, depending on what type of serialization strategy you choose, or you just delegate to the serializer of T. You don't need to know that. So you need to define just once something that deals with options. And the same principle applies to maps, or sequences, or tries, or anything that you can think of. For every, you can think of it as like wrappers on top of wrappers, right? So for every type of layer, not even every layer, every type, you just need to figure out how to deal with it once, and then you tell the compiler, okay, I can deal with options of any type T as long as you provide for me the serializer that deals with that type. I don't know how a person gets serialized into JSON, and I don't care. But I do know how to, just ignore the result or include it depending on whether or not my option has a value in it, right? So that is a very powerful thing, because what it basically means is the compiler handles the wiring for you to an arbitrary nesting level, right? You define a serializer of option, you define a serializer of string, you define a serializer of map. Now you can serialize and deserialize freely a map from string to an option of a sequence of an option of a map from string to string, right? To any level of nesting. It can be 6,000 levels of nesting deep, you don't care. The compiler will do all the recursive resolution for you. A different example might be sorting, right? Sorting an array. If you want to sort an array based on, some domain object, in Java, you would typically need to construct this nested set of comparators, right? It's a comparator of a person based on a comparator of a string. Is it type insensitive or not? You need to do all of that wiring by hand, which is not too horrible, but is not a lot of fun. So here the compiler does everything for you. I'm going to show you an example in a sec, and hopefully it'll make more sense. But first, let's see how that is actually better. It's better for performance because there's no runtime reflection involved, right? Basically, all of the reasoning happens at compile time, right? So there's no reflective access and there's no runtime code generation to deal with the serialization. Everything happens ahead of time at compile time, right? So it means that you can't. It means that you don't lose don't lose the performance required, right? Because if for instance, really old JSON serialization or XML serialization libraries in Java typically use reflection to actually, instantiate and generate your objects and set fields and such. And that is slow, right? That is incredibly slow. That is why pretty much every modern serialization library moved to code generation, right? They actually generate classes on the fly that produce or read in, instances of your domain object. And that code generation happens at runtime, and it gets cached. So it's not a horrible price to pay, but it's, you know, it's a cost at the startup of your application. It's a cost on your permgen space or meta space, whatever. You actually need to generate the code. You need to cache it. You need to keep those classes in memory in your class loader. It means extra pressure on your garbage collector. It means that, you know, permgen GCs happen more often. And depending on the level of complexity, you know, if your object graph is complex enough, you might actually run out of memory or run out of, you know, meta space you don't get to run out of. But if you had sufficiently complex object graphs and you use JSON, you would have to increase your permgen space if you use Java 7, right? You probably ran into that problem sooner or later in your careers. So you would want to know that ahead of time. You do not want to run into that issue at runtime, and also you do not want to pay the performance penalty of having to do all of that setup. Even if Jackson does it for you, it's still costly, right? So you can avoid all of that. More importantly, it aids reliability, because if you're trying to serialize or deserialize an object and you do not have a serializer for that particular type in scope, right? You do not have it in a place that the compiler can reach and pick it and give it to you, then you get a compile time error, right? You cannot get, if you use type classes for serialization, and pretty much all major serialization libraries for Scala use this pattern, right? Because it's a good pattern. You cannot run into a situation where you only find out at runtime that you cannot actually deal with a certain type. Right? It cannot happen. You get it at compile time. Also, it does not lose data, because everything happens at compile time. You have all the information, right? You do not have to deal with erasure. You do not have to deal with sugar. And by sugar, I mean, it's not a weird word that I just stuck in here, right? By sugar, I mean different languages that are not Java 7 or older do not have a one-to-one mapping with the generated bytecode, right? Java 7 practically maps directly to Java bytecode. Java 8 does not. If you have a lambda in your Java code, the bytecode does not match exactly. You cannot just decompile your bytecode and get practically the same Java code, because it gets transformed by the compiler during compilation, and the resulting bytecode is different. So that's a lossy conversion. Right? If then you or Jackson on your behalf tries to figure out what the types are at runtime, you're actually losing information, and you have to do a lot of hackery to work around that. So this is lossless, right? It happens at compile time. And you don't need to write shitty tests just because everything happens at runtime, right? You don't need to write a serialization, deserialization test just to make sure that Jackson will not blow up on you at runtime, right? So that saves a bunch of work, and it saves a bunch of annoyances. Now, just to give you an idea of what that actually looks like, I will share with you later a GitHub repo, and the reason I cannot share it with you now is because I haven't uploaded it to GitHub yet, because I'm lazy. There is a sample implementation of the serialization framework, and by sample I mean I wrote it yesterday during a talk while hungover and tired as hell. So it's probably not a very good implementation, right? But it uses this pattern and it does work. What instead I'm going to do is I'm going to show you how this is implemented by a proper library, which is the Play JSON library. Play framework, as you might know, is a full-blown web framework that supports both Java and Scala. It's written in Scala, and it comes with a very, very nice JSON API, which we will find out momentarily if I can actually remember what it looks like. So, you know, let's make up an object graph, right? We have an address, right? It's got a street, it's got a city, it's got a street or house number. Well, what else is in an address? Whatever, I don't care. We have a person with a name and a surname and an age and an address. Now, with Jackson, if I try to serialize person as is, it might work, it might not, right? Because it runs at runtime. It does runtime reflection. It does its best effort, which is a pretty good effort, right? But it does its best effort to figure out what the structure of the person class is. Then it sees the address, and it tries its best to figure out what the structure of address is. And eventually, the result may or may not make sense. It's hard to predict in advance. That was my point about predictability. Conversely, with JSON, what I need to do is I need to define this implicit keyword means that this thing that I'm now going to be defining is included in the compiler's implicit search scope. So just to exemplify, right, I have here a person format, which is basically a serializer in the serializer for a person for this library. And I'm going to ask for a format for person. What do you think? This is fully automatic, right? This does basically compile time reflection. It looks at the class, it tries to figure out the structure. Everything happens at compile time, though. So if I try to do this at compile time, what I'm going to get is I'm going to get a compile error. And the reason is because the compiler looks at this person class, and it sees the address field, and it says, do I know how to serialize or deserialize an address field? No, because no one gave me a serializer for address, and it's a custom type. So I can't just assume that I know what the structure is. I'm going to throw a compile time error. And the error is no implicit format for address available. So if I add an implicit address format, and you'll notice that I'm using this JSON format thing, right? I'm passing it a type. This is actually a Scala macro, and a Scala macro is essentially compile time code generation, right? But in a type-safe way. This is a pretty advanced feature. I'm certainly not going to be discussing it now, but the fact is that it happens at compile time. So a piece of code within the play.json library runs at compile time, looks at this class, and tries to figure out whether or not it can deal with it. And if it can't, that's a compile error, right? You cannot fuck it up. You cannot get to the point where at runtime you get a runtime error because you never registered a Jackson module that deals with Scala case classes or whatnot. You just can't get there. So it's a lot more reliable. So I have now an address format. And this, just generating this format essentially does the same as Jackson does at runtime, except it has more information and it's safer. And now I can actually have a person format. JSON.format person. Awesome. I have me a format. Now let's see if this works, right? I have JSON to JSON, person who's called Jeffrey Lebowski. He's 47. He lives in, 607, I think, Venezia Road, something like that in Venice. Don't ask me why I remember that, because I might answer. What's that?
You forgot the address.
No, this is the address. Oh, right, sorry. No, it's a previous example that I once used. Right, so the street is Venezia Road, which I'm probably mispronouncing. It's in Venice, and the street number is 607. And the address is closed, the person is closed. Now, assuming I didn't screw anything up, I get here a JSON object. And you'll notice that it's not actually a string, right? It's an in-memory JSON representation. So I might want to pretty print it. So JSON.prettyprint. In the Scala REPL, you automatically get assigned a value for everything that you run. So in this case, it's result 6. Voila. I have here a serialized JSON for my case classes. Everything happened in compile time. No reflection. Completely type safe. Extensible, by the way, because I can always add my own custom serializers for anything that I feel like, if it's something that is not supported out of the box by play.json. And it's all completely type safe, and I don't lose any performance on runtime reflection or code generation. I don't have to write tests because I know that if it compiles, it works, because it cannot compile if it does not work. Right? I may need to test my custom serializers if I have any. But in terms of composing already tested bits of serialization code, if it compiles and it type checks, then it cannot fail. And that is a very, very powerful thing, because it means that you cannot screw up. So that's, I think, all I have on this. Any questions? comments, thoughts? Right, let's see if there's anything else here. So we discussed how is that better. And we're done. So if there are no questions, if you wanna talk about anything Scala centric, go ahead. This is as good a time as any. I'm in no rush. Oh yeah. There's my email address, LinkedIn, Twitter, etc. here. If you have any questions, you need help with something, if you need help and I'm not available, I'm not gonna help you because I'm not there. But I mean, generally speaking, feel free to ask anything, even if it seems like a stupid question. I'll do my best to help. And obviously, as might be understood from the fact that we're actually having this little meetup here at the Wix offices, obviously we're hiring and we're working with Scala, and we're very excited about Scala. We've been doing that for, 4.5 years now, I think? 4 years, something like that. It's been working really well for us. We would be happy if you wanted to work with us. We would be not quite as happy, but also happy if you decide to forgo Java for Scala, because it's a much better language. And thank you very much for your time. Cheers.
Спасибо.
Right, go away.